Hey everyone, here's Hyperbola Day 2 notes. We're going to be working through 5 example problems together, and then you hopefully have this worksheet with you already. If not, you can print it off the online calendar or just jot down the information as we go. Okay, so on number 1 here, well, right above it, I've got 4 things are needed in order to write the equation of a hyperbola. We need the center, the value of a and b, and whether it is vertical or horizontal. If only a or b is known, sometimes c must be used to calculate the other crucial missing variable. So we have the formula c squared equals a squared plus b squared, which, doesn't that remind you of the Pythagorean theorem? Same thing would be needed to achieve this. Okay, so number 1, write the equation of a hyperbola with the following properties. The hyperbola is horizontal. The coordinate of the center is 7, -1. The transverse axis is 18, and b is 12. So filling in the blanks over here, it told us that the center was at 7, -1. So let's just write that down right there, 7, -1. It gives us b as well, and it's 12. It tells us that the transverse axis is 18, so remember, the transverse axis is 2 times a. So if 2 times a is 18, then a is 9. And then to figure out if it's vertical or horizontal, well, it told us. But that means that in our equation, the x squared term will be on the left. So because it was horizontal, we'll put x minus the x value of the center squared. Over here, the y value of the center, y minus -1 is y plus 1 squared. It's always equal to 1. And then remember for hyperbolas, the a squared and the b squared always stay in the same place. It's the x and the y that move. So a squared would be 81, and b squared would be 144. But I did just make a little mistake, and it was right here on that sign in the middle. Remember that it's always the difference, right? So it's always a minus sign right there. So don't make that mistake. That was a habit from the ellipse unit. Okay, let's look at number 2. Okay, on number 2, so we have the hyperbola is vertical, so I'm going to go ahead and circle that. Vertical. The coordinate of the center is -6, 4, so let's just jot that down right there, -6, 4. The length of the transverse axis is 8. Again, that is 2 times a for the transverse axis, so then a is 4. And it tells us that c is 6, but we need b for the equation. So we're going to use that c squared equals a squared plus b squared. So we'll have 36 equals a squared is 16 plus b squared. So we get b squared equals 20. So then b is the square root of 20. So the square root of 20. Okay, because it is vertical, that means the y squared term will be on the left. So we'll have y minus the y value of the center. So y minus 4 squared. Or there's always a minus sign in the middle. Then we have x minus -6, so x plus 6 squared. It's always equal to 1. A squared is always first, so we have 16. And then b squared is always second, so we have 20. So you can see these go really quickly if you know what you're looking for. Number 3. Okay, so we have vertices at -2, 1 and -2, 11. And foci are at -2, 0 and -2, 12. So the center, you could look either at the pair of vertices or the foci. Either one will give you the center using the midpoint formula. So the center will be -2 plus -2 divided by 2 is still -2. But 1 plus 11 is 12 divided by 2. You get 6. A is the distance from this center to either of the vertices. So from 6 to 1 or 6 to 11, that is 5 units away. C is from the center to either of the foci. So from 6 to 0 or 6 to 12, either way, it is 6 units away. But we need b, so again we're going to use that formula. C squared equals a squared plus b squared. So we'll get 36 equals 25 plus b squared. So then b squared is equal to 11. B would be the square root of 11. So b is the square root of 11. And then between the vertical and horizontal, so just look at the direction that the vertices and the foci are going. They all have the same y value, so that means they'll be lined up left to right of each other. So it's going to be going horizontal. Horizontal means the x squared is going to be on the left. Just kidding. Rewind. Okay. That was bad. Let's look at that again. They do not have the same y value. They all have the same x value, so that means they're going to be lined up on the line y, or x equals -2, so they're lined up above and below each other. Vertical. That means the y squared is on the left. Sorry. Hopefully you caught that before I even said anything. Okay. So the y squared will be on the left. So then we will have y minus 6 squared over a squared is always first, minus x minus -2 is x plus 2 squared over b squared, which is 11, equals 1. Okay, now let's look at number 4. Okay, now on to number 4. So it says here to make a quick sketch of the hyperbola. Number 3 said that as well. But then use a sketch to help write the equation of a hyperbola with the following properties. Maybe I wouldn't have made that mistake on that other one if I had done a sketch. But on number 4, the foci will have foci at 9, 2, so somewhere out here, and -11, 2. Way far apart. And then the a value will be 6. So the center will be right in the middle of the two foci. So 9 plus -11 divided by 2. So we get -1. And then 2 plus 2 divided by 2 is still 2. It told us that a is 6. So if the center is at -1, 2, I did a bad job drawing there. Okay. C will be the distance from the center to either of the foci. So from -1 to -11 or -1 to 9, either way is 10 units. And then we'll use the c squared is equal to a squared plus b squared. So we'll get 100 equals 36 plus b squared. So b squared is 64. Whoa. B squared is 64, so then B is 8. Because the foci are going left to right, it means the entire thing is horizontal. Because it's horizontal, the x squared will be on the left. So we'll have x plus 1 squared over a squared, which is 36, minus y minus 2 squared over b squared, which is 64, equals 1. And now we have one more. We have vertices at -6, 1 and 2, 1, and then we have slopes at positive and -3/4. So let's just go ahead and draw a sketch of this. So if we have the vertices are at -1, 2, 3, 4, 5, 6, 1, and 2, 1. And the slopes of the asymptotes is positive, -3/4. So let's figure out what the center would be. So -6 plus 2, so -4 divided by 2 is -2. So the center right here is at -2, 1. And the distance from the center to the vertex is 4, which is be A. And it is going left to right, so it is horizontal, which means that x squared will be on the left. And now here's the thing about the slopes. And you may want to jot this down somewhere on your paper. For a horizontal slope, the slopes for the asymptotes will be positive and negative b over a. But for vertical, it'll be positive and negative a over b. So let's look at this one here. So if we have a horizontal, so we're expecting this to be plus and minus b over a. So if we go up 1, 2, 3, and then over 4, that will get us to this corner here. So let's use a different color. So then if I draw in my central rectangle, so 1, 2, 3, 4. So I'll go down here, back up through this vertex, and then across here. So let's check this out. So if we go up 3 and then over 4, that'll get us to this corner over here. And if we go down 3 over 4, that will get us to this corner over here. So that works out. So because it is horizontal, this was B over A. So then now we know that B is 3. So if you're given the slope, that's great news because you know the values for B and A right away. Okay, so the x squared is first. We'll have x plus 2 squared minus, well, that y minus 1 squared. It's always equal to 1. A squared is always on the left. B squared is always on the right. And there's your equation. All right, let me know if you have any questions, and I will see you in class. Bye.